Hello everyone. Today we want to talk about the Rust programming language in general. We want to mention a lot of the good sides that we all know probably, or everyone that had a basic knowledge of what is Rust would have heard about it. We have a lot of less known things that probably many people do not mention in their buzzy stuff about Rust. And we have some facts that I really don't like about it. Not all of them are pure mature or straightforward attacking the language. You know, if you're a Rust fan, do not come back to me. Don't try to kill me. They're just my ideas, and maybe I'm wrong on some of them. On some of them, I guess I'm not wrong, but on some of them, I may be. Yep. I guess everyone that hears the Rust name probably know it's fast. But why being fast is so mentioned is like C and CPP are also fast. Assembly can be very fast if you know what you are doing. So why Rust is that important? The reason is that Rust can be very high level or very high level looking at the same time as well. You can abstract out many things in a way that you really do not feel as if it's a low-level programming language. You feel like something more like Python. I mean, sometimes the skeleton would appear and you would have to deal with a lot of borrow checks, and you would fastly be reminded that it's not Python, you're dealing with another language, a whole other beast. But sometimes you really go in the flow and do not remember that. I got this feeling many times when working with Pest and the inner system of Rust, that I would go in depth about them. That sometimes I really felt like, okay, that's the productivity speed of me in Python, just with more speed and less deployment time bugs. And that was one of the greatest feelings that I ever had. And yeah, as a disclaimer, I was and I am a Python developer as my main developing language, but I'm giving a try to Rust. I'm around a year or something doing Rust. Before it wasn't nothing serious. Still, it's like nothing serious yet. I'm just learning it slowly, taking my time with it. So, why it's fast? Well, simple answer, because LLVM, because compiled. It's no overhead, nothing like Python or other languages that are not compiled and are rather interpreted. Also, I may mention some other stuff in next podcast on the fact of the new way that you can speed up your Python to a compiler level language, because a new compiler is being made. Yeah, another one of those compilers. Yeah, I really don't want to mention more about that now, and I won't even spoil the name. You can search it if you want to find it out. It's compiled, nothing much, and use LLVM as the backend, so it can have all of the possible optimizations that you can get with CLang, and it's available broadly everywhere, sorta, not exactly everywhere, but mostly everywhere that CLCPP are available. So with that, I can jump onto the next thing, and that's embedded. Yeah, if it's available everywhere and it's so darn fast, then it makes sense that it can be used also on microchips and stuff like that as well. So another use case of Rust programming language is on embedded. Embedded use case is actually a very cool use case of Rust. Have you ever tried to write some sort of code for like AVR at Mega 16, at Mega 32, or at Mega 8, or at Mega 328 that is used in Arduino Uno? Well, if you ever had to do it without Arduino, you know that if you are a Windows user, you have to use something among the lines of there was a weird software that I forgot the name of it, but most of the normal software used in Windows is either Bascom, there is CodeVision, AVR Studio, Atmel Studio, and now Microchip Studio that do those stuff. I really never tried and used the Atmel Studio and the Microchip Studio, because the newer the software, the harder to get it set up on those old school chips. Yeah, and it's really hard to find material on using new tools for embedded project. I don't know what's the deal exactly, but yeah, that's a weird problem the embedded people can feel. I'm not sure exactly AVR is experimental support. I guess it's not the support, it's not yet fully merged, but you can see some books and stuff that they are developing on writing Rust on.
Arian from Future, it's still a nightly feature, and there is a book at book.avr-rust.com which you can read to learn more about using Rust on AVR.
AVR platform, there are other problems probably out there, like how to program and stuff. Probably you should use AVR Dude. That is not a full Rust tool, and it won't satisfy the Rusticians, but yeah, I think it should be possible with nightly stuff to really compile your AVR code and compile and program an AVR chip from ground up in Rust. Yeah, so that's another cool use case of Rust that I wanted to mention, the embedded systems and stuff like that. If you want to do and go CPP embedded and stuff like that, you would have AVR, GCC and stuff like that. You have maybe, I think, C-Lang support. Yeah, another fun fact, LLVM is still not totally and completely migrated to having support for AVR. There are still some minor problems, it seems like, that they didn't totally fix, and therefore I think that's the reason for Rust nightly support for AVR. But while AVR, GCC and GCC project has a very good support for AVR for many years now, and the mixture of AVR, GCC and AVR Dude is a great combo, both by hosted on GNU, and I think AVR GCC is GNU, but AVR Dude is a non-GNU project on GNU stuff, something like that. I forgot really the weird terminology they have in the GNU Sawana. Another topic, another famous thing that we usually hear about is great WASM support. Well, I guess everybody here wants about the WASM, but if you didn't, well, WASM is WebAssembly, and that's a technology that tries to bring all language to web. Anything that can make WebAssembly would eventually become a web programming language in front end and get access to DOM and many other stuff, and probably making JS go obsolete in long run if they really merge good engines. And Rust is actually very great in that. The support is great. There are many great tools being made there. It's not still top notch. If it was, probably everybody was using it or trying to go to. But it's like, we're trying. We would get there one day probably. That's the ideology there. And there's a thing about web apps. You need to get that done and get that done fast. And getting things done fast in Rust is not really the thing. You get things done correct in Rust, and correct and fast don't go together very well. So yeah, I think it may never really become a very big thing, but I'm looking forward to overallity of the WebAssembly, and WebAssembly support is really like they are really hustling to add WebAssembly and those stuff to Rust. I can really feel like, actually, let me get into that topic. I want to jump onto another less known good thing of Rust, that is macros. I would explain it sort of here. Rust macros are super power, and you would feel it if you try to use U and HTML. I'm actually quoting this one from the No Boilerplate video. Kudos to him. Check him out in YouTube and stuff like that. Thing about Rust macros and U is that if you ever wrote JSX, and I wrote it once and that project never ended, hint and spoiler, the thing about it is that it's really not JS. That's not valid JS. If you write JSX or TSX, those are not valid JS. They should be converted to valid JS. That they really wanted to use the word compile before, but that's not compilation, that's transcription or some transpilation. Those random webby terms, I never remember them.
Another time Arian from future, unfortunately they are right, and the process is called as compile. I'll dedicate a full episode to those terminologies.
Yeah, I think they really wanted to have a cute compiler language and they never had in their life, so they really try to borrow that term from the real compiler language, and they finally got it sort of with their cute little WebAssembly to compile the stuff. But writing JS6 would need many levels of changing your code and many level of semantic analysis of your code to turn your code to some valid JS that doesn't contain those stuff and would work out. So you don't use JS as a command because JS is more of a standard that would be developed by different engines and Node and Deno and now even Bun that sort of make a cloud of JS, with exceptions of Bun that has support for TS6 and JS6. And I really don't know it was TS6 or JS6.
Because it's both.
Any other of those mentioned here do not have a standard built-in support for JS6 and TS6. I won't mention them any more time. Just when I say JS6, I also mean TS6 in TypeScript world and stuff like that. But in Rust, if you write HTML, exclamation mark, curly brackets open, you can write valid HTML there, and Rust supports making your own sort of language, their own token and stuff like that in that block, and you can write valid HTML that would be parsed. There are other weird things that they have done with it, like the inline Python project that I talk about is more that you can write literally Python, valid Python, and as far as I saw, every valid Python that I ever tried. Maybe I should try some really weird syntaxes like yields from and stuff like that to check that is it like all Python for real. But as far as I saw, it was all Python for real, and it supported literally all Python to be written in a macro block of Rust, and that's like impressive. No programming language I have ever saw to have such a macro system. It's totally new, and it's a great idea of Rust to have to standardize something that was a problem in other languages like C and CPP. Like macro was a pain there. You could literally write code. There was a joke, meme trollish thing on internet that was going on, that they replaced every part of the hello world code, every token of it, with some repetitions of oo or o, and they like made them mo, and like that was the code of them. And they had a lot of the hash define blocks that they defined that like this is iOS stream, this is use, this is that, and that was sort of like just a string replacer. So that was an absolute pain and no good for development. Macro is like something to really check out in Rust. I would have some bad words about macro as well a bit later. I never wrote a macro in Rust, disclaimer. I just use macros in Rust. Even very basic macros, I never wrote them. Sort of weird. I have one or two crate, and I really never wrote a macro. But yeah, macros in Rust can be very powerful and give you some weird things. I just take a fast look at what they are sort of doing, got an idea, and I was like, I'm not gonna mess with this today. Yeah, another feature that like everybody when they talk Rust would remember this one, and I think it's a bit overrated feature of Rust, is the borrow check system. These days there are many ideas coming out that they try to sort of fix this. It was like the age-old problem, $1 million problem of programming language in the 21st century, I guess. How to make a language that feel like garbage collected, have a speed of non-garbage collected, and like the smoothness safety and ease of that with the other things of that other languages that are not garbage collected, the speed of the not garbage collected language and other things. And Rust took a totally different approach there. First of all, everything in Rust by default is not mutable. Everything that do not have the clone trait implemented in it. I'm not wrong. I guess maybe I'm wrong, but there was only clone or something. I forgot the thing. We have a function clone that I think is in the trait clone, but there was some other thing that if you implement that one, it would by default clone. Like for example, integers. If you like write int of a, it will move it by value. It won't move it by reference and those stuff like that.
I meant copy trait. Also, integers are 64-bit or something, which make no sense for them to pass around pointer for them.
And to make something to work like that, it had a specific thing to always do a dot clone instead of moving it by reference. And I forgot that trait name right now. Yeah, I'm saying I'm really a Rust noob. But there are some gimmicks and stuff, and every time you actually use a value, you sort of send it there and lose the control over it, sort of, until it give it back to you. Or it's somehow like there is one main owner of an value. Actually, I really didn't mess with that part of Rust much either. My code was rather very get shit done stuff in Rust, and my get shit done wasn't really using those weird data transfers. I was not using that part of Rust much, and yeah, those are stuff that sometimes I use, and like, you know, I just Sequoia Flu and ChatGPT and other stuff around them, preferably. And I think they are a bit overrated because they are not as easy to work with, and not like I didn't search them. I mean, I learned many things just by searching and stuff, and I saw a lot of stuff, but still it's obviously a constraint thing that you need to somehow, it's not magical, you know, like you still have to use boxes to move something to memory. You still have to use those ref cells and RC blocks and ARC blocks that to somehow like tell the compiler what's happening there. I mean, if you tell it, it would help you, but sometimes it's hard to even get as a developer what you want to do. You know, you should think more about what you exactly want to do, and sometimes some stuff gets really complicated and you could do it simply in another language, probably safely, maybe not, and it didn't just came into your way. So if you really know what you are doing and you want to make a really low level weird shit that use a lot of pointer passing and stuff like that, don't use Rust probably, or actually use Rust and implement it for us to use it without using those dangerous unsafe blocks if you really know what you're doing. But yeah, it's not easy, and we sort of as Rust developers hate using unsafe blocks because unsafe is unsafe. Though I think it's also another weird thing, some stuff can really be done fast in unsafe, and yeah, they are less than what we first think. Many things can be done safe and fast, but there are some unsafes, you know, you can't fully tiptoe around it. You sometimes have to use unsafe in some low level stuff. Yep. Let's go to some a bit deeper stuff. I didn't really explain the borrow check stuff very well because I'm really not a good one on it, and I'm actually saying that it's overrated a bit, part of the language. If you really want to know more about how the data stuff work, the borrow and ownership and these concepts in Rust, I think the best way is to check YouTube on this topic, and you would find probably way better content than stuff that I am saying right now. And I think though they're like Code to the Moon or Novel Operator, especially Code to the Moon, have very informative videos about how to get things done. in Rust. Let's go to some a bit more not as much mainstream features that are really great in Rust. For example, cargo. Yeah, many people don't know about cargo, but cargo is, in my opinion, the best package manager ever. One of my biggest problems in developing code in Python was that whenever I wanted to use Python, apart from I couldn't write embedded, MicroPython is absolute bullshit. Whenever I wanted to write Python, I had some big problems with package managing in project. And pip install a library or software generally for everyone to use. It's not extensible, it's not made for 21st century because Python is a very old language, I guess older than Java even for a bit. The language for that time was a great language, I say, and I still use it and I still love Python. And it's a rich library system and it's Zenistic syntax and it's like not getting in your way much. It's a really great programming language. I don't know, there is not much to ask more from a language really. But there are some static typing and those stuff problem. And these things that I'm saying here that are better in Rust and are not really done well in Python programming language. So why cargo is so great actually? That's a good question to be asked. Like why I love cargo so much. First of all, cargo make developing project easy. You don't need to deal with random other things to get your project, things like Hatch or Poetry or the other one that I never used and I always forget his name, and it's also by PyPa.
I meant PDM.
PyP? I guess PyPa. And I also never used that one. But my main tool in Python was Poetry, and Poetry plus Peep is still worse than Cargo. Cargo have it all in and is still more extensible, better, more mature. It's like all. It's one tool to go for anything that you want to do. It run your project, it build your project, it test your project, it dock your project. Anything you need to do in a project scale, it get it done for you and it get it done good. So yeah, using Cargo and Cargo Package Manager make developing projects and creates damn easy and enjoyable. Something that I never felt. And the project structure makes sense from the moment of creation. It's initialize a Git repo for you, cargo.toml and a simple hello world, and everything makes sense. You just kickstart your work from there. And it has many good extensions to work with. Many features of those extensions that were too good actually over time merged with the Cargo project itself. They are really doing the best work, I think, in Rust. Well, they are the best part of Rust, I can even say. And it's weird how underrated it is. Like, everybody talk, oh fast, oh compiler, oh this. Nobody say, oh macro, oh cargo. Holy shit, let's make something like that actually. Like, if we think deep, what's the real problem of C and CPP projects? CPP project, you can say it's a bloat of features, but the C is that who the hell can even start with the problems of C and different builders and CMake and God knows Meso, Ninja, and none of them are written in damn C even. None of them is written in damn C. So whenever you want to work in your programming language, you really need to use tools that are not even written in your programming language if you are a C or CPP developer to even build your damn project. That's a big problem. And I really do not like that. If I was a C or CPP developer, thanks God I'm not. The only close contact I have with C and CPP was doing some random mass projects for some code competitions. And for Qt, and once I was trying to work with Lua and made it a bit safer and stuff, make a sandbox version of Lua in another project of mine that I had to work with C and CPP, and I really had to really deeply dive into the Lua code for that one, that I really had to deeply dive in CPP and C, because Lua is sort of between them, like it's as far as I see, it's sort of like C and CPP deal is exactly, it's weird. You can compile it with C, you can compile it with CPP, and it give you exceptions if you compile it with CPP. It's really fucking weird. It doesn't make any damn sense. Like, they are one language, they are two language. One is hated, another one is thing, and none of them have a damn easy way to add a library. Every time you better start writing the damn thing on yourself, or try to install it somehow with the system package manager, or those new tools that none of them are standard and none of them are straightforward to set up and make sense and be used cross-platform. We have VC package, we have MS stuff. I really see. I developed this and I really have no clue. Even the names, like I forgot them. I messed them up right now. I'm not saying I'm a senior C or CPP developer. I'm barely junior, probably not even junior. But I mean, those are beasts. You in Rust is just like cargo everything. Cargo everywhere, and it works. In C and CPP, it doesn't. Even it's like the main idea of many good new language. If you want to have a good new language, you have to have a good unified CLI interface, a good unified ecosystem and CLI interface. We have it in Zig that has many features. We have it in Bon that has a very cute, easy to use CLI. We have it in Rust. And I think any other good programming language, also any other good modern programming language, will have a good CLI and CI and ecosystem as a whole. And something that I really appreciated, also another, I think that's the last fact I want to say about Cargo, is that adding package to Cargo and stuff like that at first was a bit pain, but then Cargo Edit came, a great extension. We have the Cargo Bean or Bean Cargo or something like that made installing binary files easier. Even the ecosystem of extensions of it is great, and some of them, I guess the added stuff is now merged into the Cargo, and there are many good flags. There are a lot of good help. Like, if you really want to learn Rust, the errors make sense. Actually, that's the next thing I want to say. Errors in Rust usually make sense. When they don't make sense, God bless you though, because no one else can. But usually errors in Rust make sense, and they exactly pinpoint the part of code. Something that Python these days is sort of like a copycat. Every good feature that Rust add, they are like, maybe we should add it. Like the poetry and stuff was sort of like, maybe we should copy the Cargo thing, and the match statement in Python is very closely related to what's going on with Rust, and the error pinpointing to specific parts and tokens, not the whole line, is also, and making errors overall better, also another part of Rust. Actually, Rust and Python community are sort of the same idea. They like a Zenistic, clean programming language. They are the farthest from the PHP developers, that want to get shit done.
Sorry, not sorry for the violation.
Just get shit done and nothing more. There is also can be done even in macros that sort of like feel weird, like it can give you an HTML error in the middle of your code that's totally being compiled by Rust and not invoking any other secondary code. This is a nice thing. And No Boilerplate YouTube channel also has some very good content about good errors, though I'm a bit always like not exactly in the side of No Boilerplate. I rather the Code to the Moon approach more, because he's more informative, and No Boilerplate sometimes feel like, those GNU Emacs stuff that they came out and it was like the Church of Emacs. He's like in the Church of Rust. He really adore and worship Rust. It's like more than just liking it as a programming language. I'm sort of worried for him. If by any chance he's listening to this, I'm joking, man. Yeah, the machine error. What's next? Best enums ever. Yeah, enums in Rust are so powerful that they are non-handling and they are error handling of the language, and I mean it literally. The result type is error handling and it's an enum. An option type is also another enum, and it's how the nons are being handled explicitly instead of implicitly. That's another good thing in the two good other things in Rust are these two things. So if you really want to panic your code and not raise an exception, you just write a panic. That's also another macro, just like the print and println. We get into the bad things sections. More on that. Result and option are possible because Rust supports something called as an algebraic enum. What is an algebraic enum? It means that one enum can have fields, like function fields, that can be extracted out of it in a seamless way called as a match clause. And statements are not just constructing. Sometimes some statements are decomposing structure and putting values in the side. If you're a Python developer, you see it in the match case. When you put a variable there and you say something is equal to this thing and parentheses open something, you're not making that thing. You're actually saying the thing on the right side is a sort of object that matches the left side and has that thing as first argument and the second argument, and you're sort of actually assigning values and like decomposing into the smaller parts of it. It was possible in Python, but Rust took it to a whole other new level. That's also another cool thing that you can do. So it means that, for example, non or option that handles all the nons and make them non-implicit has two types or two variants of enum. I really don't know what they call the childs of enum. It's a sum that takes a value x and it's none. So whenever, and it's a generic on any type you give it, the sum part. So if it's a none, it's just a none. If it's a sum, it's some value. So every type is not like you can't just throw a none on it. If you want to throw a none and pass a none around, you should make it an option. And the same thing is with result. What with the difference? It takes two. Each part is algebraic. So we have the result has the OK and error. That OK part is like it worked, and this is your data x inside of the OK, and error and y in like the error part. There is a small problem here that I have with Rust, and that's you can pass anything as error. That's not a good thing, to be honest. I think on long run, you can write very shitty code if you really don't be careful on that one. It can get very ugly very soon. So that's one of my small things. I really don't want to add it in that section of my problems with Rust, but it's not ideal. I think they could make it better and more. Maybe they could make it better. Overall, the experience of it that every time you have to match it in an if-let statement is also a little constraining for especially new developers to the world of Rust. That's a little bit of pain, I think, that many people really won't like learning Rust, and it would degrade the learning experience of the programming language overall. Yup. What else we have? We have great match and match statements. I talked about the match sort of type. We have a statement. We have oh god, do I really want to forget this right now? We have a statement. We also have something that's returned. The whole idea of using the other thing I really want to talk about is that
I meant expressions.
Semicolon makes sense in Rust. It's not like just dog shit. I think it still can become better. There is more chance for improvement. I actually had some ideas and I wrote it down and tried to make it make more sense and stuff. It's a bit awkward, but I think it's like better if the developer never saw any other programming language. I mean, the idea of semicolon is that they are using a very common idea and making it make sense. That's sort of cool. And expression.
No shit, Sherlock.
The term I was looking for was a statement, expression, and matching a statement, something. I really don't know. So whenever we are working with this division, these types of working with sort of, it's a whole meta class that never was being looked at this meta level and this abstract level on how things actually work in programming language. They were in their AST trees that they had this, but they never really leveraged it in this damn level. And I think it's because I love this abstraction and stuff. I really love the idea of these separations and these looks that abuse the syntax to do many damn things with, without being in a bad way. So the structures, expression, and a statement. Oh, I should talk about expression and statement. Nearly any block that you make with curly brackets can return something. You can literally make a block in the middle of your code and that would have local variables of its own, and you can return something out of it. Everything inside of it would be dead if you come out. There is if, it's while, I think while and for can't return anything, to be honest. But if a statement can, we have if, iflet, and both of them can return a stuff. And returning a stuff out of things is just if you don't put semicolon somewhere, that means that I want this to be an expression, and expressions would return. It's like a weird look on things, but every time you speak, and whenever you see an expression, whenever that means sort of returning out of it. You can even return out of an if. It's not like just doesn't need to be a function. So a normal returning of an integer, you can literally write 12 at the end of a function, and that means that this function returned 12 if it didn't exist before that, if it's last line. And it doesn't even need to be in the last line, it can be in anywhere. And you can simply pop a value out. There is some problems in popping multi-level out and still doing it that easy. Like if there is an if inside of an if and then you have some block and there is if and you really want to pop it all the way up, that is a bit hard and cannot be done.
I'm not sure it's a big no-no or it can be done and I just don't know it.
And I think there should have maybe thought about this one. But I mean, Rust have so many great new ideas that I really cannot go on them for not having enough innovation for these thoughts. They added a lot. They contributed a lot. And I'm looking forward, maybe in future they fix this problem as well, to pop something up as expression in a longer, weirder chain. Also, match statements in Rust are exhaustive. Exhaustive match statements or match arms means that you really cannot let it go with like matching two things and then not having a default. You either match every damn thing or you need to have a default form. Oh, have I ever mentioned that underscore is so damn well used in this language? If you mean there is no default, if you want to say anything else, you just put the underscore. It means ignore, and it means ignore in a deep way that makes sense. Not like in Python that it's like a convention more, not like something that is used. Whenever you put underscore, it match anything and discard its value. It doesn't matter. So it tells it to the compiler, and it literally used that as being discarded and would deduct that. That's a great thing. They really, really, really took good, easy conventions and made them to real usable rules from a start point to make language more usable. They really used as much as chances that they've got on optimizing things, on developer experience and stuff, and they made them hard rules and did optimization on anything that they could. It's another thing that I really love about Rust is how well they use their underscore. Popping back off my stacks of saying things, the match statements are exhaustive. So you have to match all parts of the arms. nearly there, this thing is being even done in a way that you can really match a number, and if that number has a range of is a U8, if you match from 0 to 255, that would be exhausted, and that's damn great and beautiful. I really love that. You can do it with enums, you can do it with actually enums, nearly the only way to take the stuff out of them is some sort of match or if let. Any other things would become weird, especially if you are using those algebraic ones, algebraic enums. Algebraic enum is one of those things that is hard to get used to, because we are always used to seeing that we make statements, not decompose statements in those weird structures. But when you get used to it, you're like, damn, why we never used them before in other languages? Yeah, another thing about Rust that I really love is that everything in Rust is somehow taught and algebraic and mathematic. Everything is algorithmic, everything is detail-oriented and abstract as much as they could. Even their generic damn system. You can add a stuff and say that if it had this or this or this, and you can AND them, and you can AND traits and stuff. The thing about Rust is that Rust is not an OOP language. Rust uses structs, and it doesn't even have classes. Sometimes I really think that if there was a better way to construct them, not just a new and big convention that I really hate, if it was actually maybe a more solid method was better. I really didn't like that part of it, but I mean, it works, and you can really see big projects of Rust that really feel like normal OOP code with structs. If you need that, you can do that. If you don't need that, you can use it like C or CPP structs, and you don't need to overthink much about those trait stuff. But with traits, you can set that something has a trait or do not have a trait or any other type of expression. What else we have in the generics world is that Rust is not a dynamic programming language. So if you really want to pass something that has some function and stuff like that, you should do it with traits. And this algebraic powerful trait make you able to, with no overhead, with no compiler and programming and speed overhead, but it's like with your developing time and thinking and overthinking overhead, you can get things done. So you put more time in development time, but you ensure the safety. It won't be like in the middle of your runtime, something say that, oh, actually this object doesn't have that function in it. You would never see that, because everything is insured, because you have to make a trait and then say that explicitly this one has that trait, or else it won't compile because of static typing. That's one of the nice things about the static typing of Rust, that it's used in debugging before you get a problem on runtime. Yeah. Even the generic types and stuff, you can pass closure. Like I would say it's more powerful than Java in things. Like Java is Java literally uses a machine that is not directly binary of system, and it's garbage collected, and it's still not as fast, and not as smooth as the Rust development experience. I think if you're a Java programmer, really get some help. And
did I say sorry, not sorry?
Maybe God forgive your sins finally if you repent to Rust. What else we see here? The feature system. Something I saw before but never worked directly with. That Rust can have some very darn good these new modern ideas of Rust. One of these new modern cool idea of Rust is that you can have specific features that you do not want to install.
Features are a feature in Rust, and sorry for it making near to no sense yet.
In a package, yeah, we have some stuff like that in Python as well, but they are not as much used as in the Rust. So features in Rust give you the ability to, if you want to have another package and have interoperability with something, you can install it with an extra feature, and that would unlock some more things to do. and you can set it with simple flags that are specified with a hashtag sign, and that's like you can list them all in the cargo.toml, and even for your dependencies you can use some of those features and do not use some of those features. I think you can even re-export your dependencies features and like build on top of them to have more interoperability and stuff, and many things like this. That's a very cool thing about feature system in Rust and Cargo, that everything is written in the cargo.toml and stuff. Another cool thing is that many things have very simple implementations. Many of these traits, like something when we have a debug thing in many languages, some of these things you need to write it on your own, or they have the default implementation. In Rust, they did it explicitly, but they did it explicitly well. You can write a derive part, and that derive like derivation, derive, D-E-R-I-V. You can derivate a version of the function that makes sense for example, for the equal or partial equal or debug or clone or other things that make it very easy to use some sane defaults for some of the traits you want to implement. It's very nice to have. It's very easy to use. It's very nice overall. If you are new to Rust and you think that oh shit, I should write debug and stuff, no, you don't have to. You can simply use drive. Another cool thing that is out there is that drive use macros of Rust. So some people made their own drives that are even more powerful than drive. One of them is the derivation itself, that is a crate that gives some extra features, like you can derive everything but specific things to be ignored, for example in debug or some other things. It's very cool. It gives some extra control in the normal derive or whatever. Something else that is really smooth in Rust is that bad documented code is hard to find, because documenting has a great reward of having a full documentation book.
Hosted for free, wink wink.
JavaDoc was a nice idea. PyDoc was a nice idea. But RustDoc is a whole other beast. Documentation in Rust has many types. All of the things that I have is some sort of commenting. Slash star slash star star slash 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 slash, all of the things I mentioned, slash slash exclamation mark slash star exclamation mark, all of them are different types of comments. That some of them are the RustDoc type of comments, and some of them are the normal comments. I guess you can guess what is the deal with the slash slash and the slash star. Those are simple normal CCBB comments. When they are followed with exclamation mark, it means that for the outer block they are documenting, and when they are followed with an extra slash for slash slash and with an extra star in a slash star star, what they do is that they let you to comment for the thing that you wrote under it. This is a very cool thing, like what we see in Python with the decorators, that the following statement you write code for it. It's very common in Rust, nearly abused, beyond use. And you can write documentations like that. You can write test, like with assert equal, another macro assert equal that would be run would run.
Sorry, my English restarted here.
When you are testing your project as a test for your code, and also work as some sort of documentation example. It's very nice, and it's nearly supports all Markdown. Like something like a Stack Overflow Markdown or GitHub Markdown. I really never experimented with exactly which type of Markdown, but you get some sort of Markdown. And whenever you publish a crate, it would automatically sync it and upload it to docs.rs. So any crate that you write, all of your documentation would be synced in an online book, documentation for everyone, without doing any damn other thing.
The free juice I mentioned before.
It's like if you well document, you really don't need to do any other damn thing for your code. And come on, in the world of OpenAI and ChatGPT and Copilot and whole other damn lots of other shits that's out there to help you write your doc, just write a simple doc and everyone can use great code. If you wrote a good code, now you can easily dock it, and Rust would do the publishing and making a cute website for that for you. Let's go to the next thing that I really love about Rust. Python interoperability of Rust is top notch. Maybe not as much as CPP deep down, but the developers of Rust really tried to make it as good as they can. Two great models that I really think should be mentioned is PyO3 and lesser known inline Python.
By modules I meant crates.
PyO3 is basically PyO3 and it's oxidized with some reasons. I really don't get why they try to oxidize it with the O3, that is ozone. But I don't know, maybe it's some sort of weird biology, weird sort of chemist reference that I don't get. But yeah, PyO3 is a great model, and inline Python utilize the features of PyO3 and implement Python syntax inside another macro, a block macro of Rust that can literally write Python. And I didn't check that it's a static, dynamic, using directly your system Python binary or some other shit that I never checked it, but it works smooth. And I think it's either static or dynamic because it made a lot of random SO files that I think it means that it's really grabbed some parts of the Python. One of the things I got is that it's probably not using directly your Python because it didn't use my imported package in the installed package of pip. So it means I think they really extract libraries and stuff of Python, libpython and stuff like that, and they use them directly in inline Python. Kudos to Fusion Engineering overall. The tools that they make, like inline Python, intbits, and all of them are great tools that help you get more stuff done out of Rust. The intbits is a great crate for using bits of a number, and they did it in such a great way that I really never worked with bits in other languages as well, to be honest, with each bit. But that's as much as I can ask for. I mean, maybe I can ask for a bit more, like giving it with Python like syntax of yeah, I can ask for more now that I think of with those Python brackets, dunders.
Set item and get item dunders.
I'm great at forgetting name.
We know.
Probably you would get used to it.
I wish you fix it, or editor, you have to continue patching this shit.
If you listen till here, up to this point. Yeah, that's thingy that they override in Python with the dunder method that I also forgot its name.
Stop it. Get some help.
But the only thing that comes in my mind right now is get attribute, but it's not get. It's get something that I forgot. Yeah, get something dunder and mention it directly like that, and it would be probably smoother even than this. But it automatically implements it for any type of your main types of your integers, your U sizes, your U8, U16, U32, any damn U and any damn I and any size. Yeah, another good check to think, just as an extra point here. We also have Martin, I guess, something.
Maturin.
I won't explain this anymore because I just saw the names in the README and passed over them. To develop projects that are like Rust in Python, Python in Rust, make a Rust library that work in Python. You can do all of those shit with Rust and Python. They are a great combo. And overall, I want to mention the fact that the docs, the features, the versions, bookmaking, even they have a special thing that most of the Rust related books are made with it, MD book something. The analysis tools, everything is a unified ecosystem that as much as it can be done, it's automated. Like you don't need to sign something in. Everything would be done automatically, and nothing is like, oh, I actually didn't want to do that most of the times. Like that doc thingy is one of the coolest things. I really loved it. That I can develop, create, put it up there, and it would make my documentation up there, and whenever you search for a package, that would be probably the first result or something. It was a really great feeling to develop something that is docked in Rust. It sort of made me to document my code. Like I really felt bad to don't have the documentation in my docs.rs folder page of I guess the page is a better word, in my docs.rs page for my crate. What else we have here? The other thing I really felt while I was developing a bit of Rust was that development starts hard, but grow isn't as hard. I mean, I read some Rust codes and I really get frustrated, but I think if I was a better Rust developer, I wouldn't. The thing is, if you get a hold of Rust, growing a project midway is easier than developing and starting some project. Because in a startup project, you need to overthink every small piece. But when you are growing your project, everything is laid down for you, like a platform that you made for yourself by force of the compiler, and then you can make any improvement better. It's like a tool to force you make better code and make things explicit.
It's like Vim but can be learned in one life.
As some other YouTubers also mentioned, I really loved it about my Rust experience. Any feature that I added went on smoothly. It was sort of joyful even to add features. Starting the project wasn't as joyful, though I should mention that. Another cool thing is that packages are yanked and not deleted. I mean, sometimes some stuff you just want to be forgotten, especially if something is not downloaded ever. You know, just get that out of my eyes and let's never that be a thing in history. But well, for good and bad of it, you can't delete a package. You can just yank a package. If you upload something up there, you can only contact them to delete it if there is a really great reason for it to be deleted, like some information being leaked or something like that. Or else your package, you can just do a yank. And what yanking means is that no new user can use it, but everybody that added it as dependency can still use your package. And they can still build their project. This is a very great dedication to backward compatibility without hurting the speed of development in Rust. There's a lot of things done in it. When there's a feature added and that feature goes, it takes a lot of time for that to really being obsolete and thrown away. Usually features, you still can use them. And they really have a great plan system for obsoleting and like adding feature and stuff like that. The whole mechanism of this is futuristic, better than anything that we have done in any other language, I think. What else we have? Package or yank and delete. Able, yeah. The last good point that I want to mention is that community is able. They do crusades for their language. You just need to check the no boilerplate or many other open source projects made for CLI that you see that they are made with love. They are almost see Rust as some sort of god that they have to mission to spread its idea like a virus.
Fun fact, Rust name is actually based on the Rust virus from botany, not metal rust.
And they are a great community. I really love them. Sometimes they get annoying because they really want to push things that they are not as well.
And sometimes their foundation fuck everything up so bad you suspect the language will survive even.
Like that result thingy, or some other thingies that are not as well. Like they want to say all of this pain is pain for development of your code and are actually good things that would later help you, that I think it's sometimes not, but overall they made great things and they proved they can do anything with Rust. The Rust community made an operation system just to prove they can, the Redux OS. The Rust community rebuilt the core utils God knows how many times in Rust. Rust community is already merging, making many new tools and making alternative for all tools that are better. The ripgrep, FD, God knows what else. They are crazy, but in a good way. They are improving the day-to-day tools and they are doing good, really. The Deno for Node, all of these alternatives are great. Great tools overall. I really want to mention some specific tools here that I use. Probably I would add some of them in the second part of this podcast. It's just the good things with some slight mentions to bad stuff in Rust that I saw. Spoiler, there are not many bad stuff about Rust that I'm gonna say. But some of the good things that I see in Rust is obviously all of the crates that I mentioned above. Very crates that I liked and I worked with and I love them. But Deno, SerialDB, many end user tools that are written in Rust. The pest that I mentioned, I guess, before as well. Bevy, I guess, also mentioned it before. All of them are great crates that give you some experience of development that I never felt in any other library of any other programming language. It's quite unique and quite easy to work with and quite easy to develop. The bigger part of good things of Rust is that it's easy to develop and build on and build on and build on and build on and go on. That's most of the things that I want to go for section 1 of this. Took 1 damn hour of me trying to remember words.
And me trying my best to fix them.
And it's just the first part of it. I probably would come back with more of Rust. I would come back with the bad parts of Rust for sure.